Okay. All right, so the second bar, he noticed is 3/4 of a representation of the first bar, right? Okay, what else would you guys say that you notice? Something that you can infer, something. Ellen? Okay, and what percentage would that be? 100%, right? So she's inferring that this would be represented as a whole, which would represent 100%. And just like Nicholas said, that this is considered to be, what's shaded here is considered to be 3/4 of that. So if that's 3/4 of that, what do each of these boxes represent? Armand, thank you. 25%. There you go. So each of these bars right here, we could infer that they are 25%. Okay, and if that means that each of these bars are 25%, then we could also make a reference to the percentage of what the 3 bars are together, which would be what? 75. Okay, so together this would be 75%, right? Okay, so we can note that because of the fact that we have 4 sections that we're splitting this 100% up into, and that's going to create that 25%. Now, I focused on percentages, but there's something more than just percentages, and I think that's what Armand was also referencing, because at first you said 20, right? But I was asking about a percentage, but 20 is also a correct answer. Why is 20 also a correct answer for just that single box, Leah?
Because it's 80
Very good. If you take that 80, which was the whole, right? We know 80 represented the whole, and we also divided that by 4. Then that's going to say that each of those sections, though they are 25%, they each individually are going to be 20. So noting that, then we can easily say that 75%, right? If we're focusing on the 75% that was highlighted, of the 80 that we're representing here, is going to be how much? 75% of 80 is going to be what? 60, right? Because if we take 20 plus 20 plus 20, that's going to equal 60. So there's different ways that we can use the tape diagram to infer about parts and wholes and percentages. Okay, so that's what we're going to be focusing on for today. So let's take a look at our very first example. It says Jada has a puppy that weighs 9 pounds. This, and again, the this that they're referring to is the information that they just gave to you, which was the 9 pounds. So when I say this, I'm referring to the 9 pounds, the weight of the puppy. That's considered to be 20% of its full-grown adult weight. So we have a diagram that's going to represent the full-grown weight as well as the weight of her puppy at that present time. Okay, so we know that currently the puppy is going to weigh 9 pounds, and that just one of these boxes we're labeling as 20%. Okay, because that's what we're stating, that the 9 pounds is 20%. So how did I know to continue adding 4 more boxes to make a total of 5 boxes? Why do you think that I continue to do that? Miles? Okay, but how do I even know what the total weight is? I have to use something else. I have to infer Luke. Yeah, we're focusing on 100%, right? The full-grown weight of the dog is going to get up to 100%. That's what we're trying to do. Well, if we know that one part of that box is 20%, then we can keep adding additional 20% until we're able to get to a total of 100%, which happens to be a total of 5 boxes. And each of those 20% represents 9 pounds. So that means when we combine all of that together, it's going to have a total adult weight of how much? 45. Okay, so we're able to find that the adult weight of the dog is going to be 45 pounds. So just stating what we did here, we know that the adult weight is going to be 45 pounds. The reason that we were able to do that is because we created 100% by multiplying the percentage we had by 5 in order to get to 100, right? And I'm writing kind of fast, which means I'm writing sloppy, and I apologize. So we created 100% by multiplying 20% by 5. And in doing so, because we multiplied the percentage by 5, then that means we also have to take the 9 pounds, which was our part, and we're also going to multiply it by 5. And that gives us that adult weight of 45 pounds. Okay, so tape diagrams basically takes that percent proportion that we learned about the other day and breaks it into more of a visualization. Now, we have another dog, Jada's friend. Her friend has a dog that currently weighs 90 pounds. So we have a diagram that's representing here the friend's dog. So I'm going to put that up top. This is our friend's dog. And then we've got the smaller diagram down here, and that's going to be Jada's puppy. Okay, so we know that Jada's puppy weighs a total of 9 pounds currently. So we're wanting to know, based off of what we're seeing here, how does that relate to the friend's dog? Okay, so when we're taking a look at this diagram, we took the weight of the friend's dog, which was 90 pounds, and we want to put it in terms of the puppy's weight, which was 9 pounds. So we're taking the 90 pounds of the dog and dividing it into equal sections of 9 pounds each. So that way it tells us how many boxes to create, which let us know that we're going to create 10 boxes. So that's where we get these 10 boxes from. And so now when we're looking at it, if I'm looking at these 10 boxes, this portion right here is what Jada's puppy is representing from the adult. A very small amount. In fact, a very small percentage. What percentage of Jada's dog is represented with inside the adult dog, Leah? 10%. Because again, we've got 10 boxes. If we take that 100% and we divide it by those 10 boxes, that's going to let us know what every single one of these percentages is going to be. Okay, so every one of these is just a 10%. All the way until we get to here, 10%. Okay, so when we're taking a look here, we can easily identify how many times greater is the dog's weight than the puppy's weight. How many times greater? 10. Not because of the percentage, but because of how many boxes we were able to split it up into. But it's 10 times greater. And if we were to compare the puppy's weight to the dog's weight using fractions, so if I'm creating this fraction, one of those values is going to have to go on top and the other one's going to have to go on the bottom. So one of them's the numerator, one of them's the denominator. The numerator is always stated first, right? When you're reading a fraction, you read numerator over denominator. It's the same thing when you're talking about setting it up. In the problem, it's always stating your numerator first, your denominator second. So the puppy's weight is going to go first. So we're putting the puppy's weight on top, which was 9. And then we're going to put the adult dog, or, here, I'll do my purple again. The dog's weight on the bottom, which happened to be 90. And if we were to simplify that, that would simplify to 1 over 10, which makes sense. 1 box, 10 boxes, all of them the same size. And then again, as percentages, we already identified the percent, 10%. All right, let's flip it on over to the back. So with here, I gave you guys the diagram. Sometimes you are going to have to create the diagram to help you out instead. So how do we know how many boxes to use, or how long or how short to make our diagrams? Some diagrams you can use and other ones are not as sensible. So if I'm taking a look here, Noah Noah's got $5. And I want to go ahead and break Noah's money up into equal parts. What's one way that I could break his money up, his $5 up, into equal dollar values or penny values, whatever you want to do? What's one way we could break it up? How can I split $5 up? Into fifths, right? Which would be how much? $1. I could split it up and make them into a single dollar. So I could create a diagram here. Where inside each one of these boxes is going to represent just $1. Now when I break it up as just a single dollar, I'm only going to have what percentage for each box? 20%, right? Each of these is going to just be a representation of 20% of the money that he's got. And as we're calculating it up, I can easily see that $2 is going to be 40%, and that 80% is going to be $4. So I can see that and visualize that. Okay, I know it again because I can take 100% and I can divide it by 5, and that's going to give me that 20%. I can also split it up even smaller increments. Okay, I could do tenths. But if I do tenths, what amount of money is that then? 50 cents. Okay, so I can split it up into 10%, where each box is 10%, or 50 cents. Let's draw that one out. Okay, so inside each of these I can put 50 cents. And just as Asa said, it would be 10%, or 1/10. Okay, so I'm going to just write 10% up at the top real quick, and then just kind of dot it along all the way until we get to 10% at the bottom. And again, the reason that we were able to do that is because he says break it up into tenths. So we're dividing it by 10. That finds our percentage, which means we're taking our money, 5, and dividing by 10, and that gives us our 50 cents. Okay, so these are different ways that we are able to express the exact same information. Both of these represents $5. Both of these represents 100% of the quantity. But one of them is going to be better used for situations than the other. Which one do you think is going to be a better use for any situation? The one with the smaller increments or the one with the larger increment? Smaller increments, right? Because it's more detailed. If you think about it, kind of think about in science. Okay, the more that you zoom in, you're able to see the fine print, the small stuff, right? With the microscope, it's the same thing. When you want to zoom in, you make things smaller details to see. You're wanting to zoom in and see every little piece of information. Okay, so when you're breaking it down, it's easier to see. Right now, this is easy to see as long as everything is counted in 20s. But if I have something that's going to go into 10s, not so easy. And then this, not so easy if I have things going in 5s. So then I'd have to go even smaller than that. So you have to think through the details. All right, here, Elena has 40% as much as Noah. So how much does Elena have? So we're talking about Elena. Elena, I'm going to highlight her in green. She's got 40%. 40% of Noah's amount. So I can use my top diagram right here. I can identify 40%. That's going to cover how many boxes? 2. 2 boxes is going to represent 40%. So then how much money does Elena have? $2. Okay, she's got $2. $2 is 40% of the $5. All right, now I want to compare Elena's money to Noah's money. So again, we're going to take Elena's money, which was $2, and we're going to put it over Noah's money, which was $5. And that's as simplified as it's going to be able to get. But now we've got a different kid, Diego. Diego has 150% as much as Noah. So who's got more money? Diego. Diego has 150%. Okay, 150% means he has everything that Noah has plus 50% more, right? So he's got all of this first diagram. That first diagram right there represents 100%. He's got 100% of Noah's money, which is the $5, plus he's got 50% more. Okay, so 50%, that's easier to see with this diagram. How many boxes do I need to cover for 50%? 5 boxes. So we've got 1, 2, 3, 4, 5 boxes. How much money is that going to be? $2.50. So then that means 150% is equal to $7.50. So he's got $7.50 compared to Noah's. So now again, we're comparing. I now want to compare Diego's money and Noah's money as a fraction. So what value is going to go on top? Diego, right? We're comparing Diego to Noah. So that means that the numerator is going to be $7.50 over our denominator, which was $5. Okay, and then you would simplify when needed. But we're trying to rush through this as quickly as we can. All right, let's take a look here. For problem number 5, we've got a tape diagram here. Top diagram's representing Priya's distance that she's walking. Tyler's distance is represented by the second diagram. So there's 2 different ways that you could be looking at the same piece of information, because notice I've got the diagram repeating twice, don't I? But in the first diagram, we're focusing on Priya compared to Tyler. In the second diagram, we're focusing on Tyler compared to Priya. Those are going to give you very different percentages. So for here, Priya, when we're focusing on Priya, each box is worth what percent? So if we're looking at just Priya, each one of her boxes is worth what percent? 20, right? We've got 5 boxes. So if we take 100 and divide it by 5, that's going to equal 20%. So that means we've got 20% for every single one of these boxes. Because again, we're taking 100% and we're dividing it by the 5 parts that we've got, and that's going to equal 20. Okay, so each one of these percentages, or boxes, is 20%. So now based off of that, we want to know what percentage of Priya's distance did Tyler walk. So here's where we're looking at Tyler. Tyler is how many boxes? 4. So we're comparing him to Priya. We're going to cover up 4 boxes for Priya, and what percentage is that going to represent? 80%. Okay, Tyler has walked 80% of Priya's amount. Tyler has walked 80% of Priya's amount. And now we're going to do the reverse. Now we're focusing on Tyler. What percentages are Tyler's boxes worth? 25. So for Tyler, he's worth 25% because we take our 100%, we're now dividing it by 4 parts, which will give us that 25. Okay, so each one of Tyler's boxes is labeled as 25%. So now when we're looking at Priya and we want to say, hey, Priya has walked what percentage of Tyler's amount? Well, Priya, not only did she walk everything that Tyler did, but she also has an extra, didn't she? She has an extra 2 here, which is an additional 25%. So what percentage did she walk? 125. I'm going to pause for a second and make sure everybody's covered with me. Any questions so far? We're okay? Okay. And tell me if I'm going too fast. 120. So I'm trying to get us done in the next 10 minutes or so that way we can get on. You have plenty of time to do that assignment. All right, go ahead and flip it to the next page. We're almost done. We're halfway there. Okay. So a real easy way to break down how you're going to build your diagrams. You've got a set of questions that you should always ask yourself, and it helps you to be able to create the diagram for you. So when you're reading a problem, right here in the problem, we've got a gas tank in a car holds 16 gallons. The gas tank in a truck holds 25% more. Okay, so if we're saying it's going to hold 25% more, does that mean it's going to be bigger or smaller than 16 gallons? Bigger, right? More than 16 gallons. So when I'm working out the problem, logistically, I should know that I'm going to get an answer that's going to be larger than 16. Okay, so here are some questions to help you along the way. First question you always ask yourself, what percentages are you dealing with? So what percentage do we see in the problem? 25%. Okay, so we're going to write that down. We're dealing with 25%. We want to know what fraction is that out of 100. So if I were to take 25 and put it over 100, what is that going to equal? 1/4, right? So that tells you how many sections you're going to create. How many sections are we going to create in our tape diagram? 4, right? Every section is going to be equal to 1/4. So we have 4 equal-sized sections that we're going to draw out here. So I'm going to go ahead and draw my little diagram. And I'm going to split it up into 4 equally sized, as easy as I can, boxes. Okay, and once again, I know that each one of these boxes is going to represent that 25% until I have a total of 100% here. All right, so now we got to figure out what goes on the inside. So the next thing that we're going to ask ourselves is, based off of the question, how many gallons is each one of these sections going to be? So only gallon information I have is 16. So I'm taking that information and I'm going to divide it equally amongst my 4 boxes. So 16 is going to get divided by those 4 boxes. And so how many gallons goes inside each box? 4, right? Each one of those boxes is going to be worth 4 gallons. Okay, so now the truck is 25% more than the car. So that means it's going to have everything that the car has plus an additional 25%. So when we're talking about it, the truck is going to equal the car, which is at 100%, which happens to be that 16, plus we're going to take 25% of the car, which happens to be 4. So when we add that together, how much does the truck have? 20. 16 plus 4 is 20. So we've got 20 gallons. Okay, I want you to do the same thing for the next problem. Read through carefully. So taking a look at the problem, Mandy purchased a new car. The gas tank in her new car holds 20% fewer gallons than her old car. So if her old car's tank held 15 gallons, we want to know how much her new car is going to hold. Okay, so what's the percentage that we see? 20%. Okay, so as a fraction, that's going to be 20 over 100, simplifies to 1/5. So how many sections are we going to have? 5. 5 different sections. Okay, so we're going to go ahead and quickly draw that. Split it up into 5 sections. Okay, and each one of those sections is worth 20%. All right, now, how many gallons will each section in the tape diagram have? So taking a look, the only information that we have within inside here is that there was a 15 gallon. So we're taking 15 gallons and we're going to divide it by 5. And so how many gallons is inside each? 3. So inside we've got 3 gallons inside each. So now the question is saying that it's going to hold 20% fewer. 20% fewer. So that means that I am removing this last 20%. That shows me 20% fewer. So how many gallons is my new car going to have? 12. My new car is going to have just 12 gallons. All right, so that's just you being able to create your own diagrams. Taking a look here, answering questions based off of the diagram that's been provided to you. So here we have an entire diagram that's representing 70 haircuts, and that's representing 100%. Okay, so 70 haircuts is 100%. So when we're taking a look here and we're filling in this information, 70 haircuts is 100%. 7 haircuts is then going to be what percentage? 10, right? Because we have 10 boxes. That means each one of these is going to be 10%. So then we want to know, what is 63 haircuts going to be? Well, this is going to be 7. This goes to 14, 21, then we have 28, then 35, and then we've got 42, 49, then we have 56, then we're going to have 63, and then 70. I'm having a brain fart, or not 56, 54. All right, there we go. No, 56. What? Jesus Christ. Whoo! My brain is going there. My 9. All right, so what percentage is 63 going to be? 90, right? If we work our way all the way up, that's going to take us all the way up to 90%. All right? Taking a look at the back. You got banjos. 15 banjos is considered to be what percentage? 100%. So now I want to know, what is 3 banjos going to be and what is 6 banjos going to be? So based off of what we're doing here, how many sections do you think we should divide 15 up into? If we're wanting to look at 3 and then at 6, we should divide it into how many sections? 5, right? We divide it into 5 sections. Okay, then we're going to be able to get up there. That's 3, 6, 9, 12, and then to 15, which means each of these percentages is going to be what? We divided it into 5 sections, then each percent is going to be 20, right? 100 divided by 5 is 20%. So we're going to have 20%, then it's going to go to 40%, then it's going to go to 60%, then it's going to go to 80%, and then it's going to go to 100%. So at 3 banjos, we're at 20%. At 6 banjos, we're at 40%. Okay, and then down here at the bottom, this time instead of us getting a full 100%, they're saying that 70% of the data provided to you is 91 minutes. So 91 minutes represents 70% of the data. So when we're looking at 70%, we're going to put in 91. 70% of it is considered to be 91. What would 10% be? So if we're looking here, each one of these boxes is worth how much? Each one of these total boxes here is worth how much? 10. Each one of these is worth 10%. So we have 10%, 20%, all the way up to here, which would be 100%. This box at the very end of our shaded region is where 70% is going. Now, all 70% is considered to be 91. So how do I figure out what's going to go on the inside of here? What do you think I need to do then, Nick? Good. Take the 91 and we're going to divide it by 7. Okay, so if we do 91 and we divide it by 7, what are we going to get? 13. So then that means this box is 13, and then we're going to go to 26, and then we're going to go to 39, and so on and so forth. Okay? So when we're taking a look, 10% is going to be only 13. When we go all the way up to 100%, what's that going to fill up to? 130. All right. So what I want you guys to do, you're going to get into your IXL. Get logged into IXL, and then you're going to the quiz section of IXL. You are closing all tabs. You have 2 minutes to get in before I open up securely to 1 tab only. So make sure you close all your tabs except for IXL.